Hi, welcome back to SQL Database Administration Hub. Today, we're going deeper into SQL Server security with a permissions deep dive. Now that you understand logins, users, and roles, it's time to learn exactly how permissions work and how to control them precisely. Let's get into it. SQL Server has a very granular permission system that gives you precise control over who can do what with your data. In this video, we'll cover three key concepts: the grant, deny, and revoke command that control permissions, how the permission hierarchy works in SQL Server, and what ownership chaining is and why it matters. By the end of this video, you'll be able to design a solid permission structure for any database environment. SQL Server uses three commands to manage permissions. Grant gives a user or role permission to perform an action. For example, to allow a user named John to read data from a table called orders,
grant select on orders to John.
revoke removes a previously granted or denied permission. It puts the user back to a neutral state, neither explicitly allowed nor explicitly denied. Revoke select on orders from John. Deny explicitly blocks a permission, even if the user has been granted that permission through a role. Deny always wins over grant. So if John is a member of a role that has select permission on orders, but you deny select to John directly, John still cannot read that table. Deny select on orders to John. This deny override behavior is critical to understand. It means you can use deny as a precision tool to block specific users from specific objects, even when their role gives them broader access. Permissions can be applied at different levels, on specific columns, tables, schemas, or entire databases. The more granular you get, the more precise your security becomes. SQL Server organizes permissions in a hierarchy, and understanding this hierarchy is key to managing security efficiently. At the top is the server level. Permissions granted here apply across the entire SQL Server instance. This is where server roles like sysadmin live. Below that is the database level. Permissions granted here apply to everything within a specific database. Database roles like db.datareader operate at this level. Below that is the schema level. A schema is a logical container for database objects like tables and views. Granting permission on a schema automatically gives access to all objects within it, both existing ones and any new ones added later. This makes schema-level permissions very efficient for managing access at scale. At the bottom is the object level. This is where you grant or deny permissions on specific tables, views, stored procedures, or even individual columns. Permissions flow down this hierarchy. If you grant a permission at a higher level, it applies to everything below it. For example, granting select on a schema gives select on all tables in that schema. As a best practice, manage permissions at the schema level where possible, and reserve object-level permissions for specific exceptions. This keeps your permission structure clean and maintainable. Ownership chaining is an important SQL Server security concept that affects how permissions work when objects reference other objects. Here's the scenario. Imagine a stored procedure owned by user A that queries a table also owned by user A. When user B executes that stored procedure, SQL Server checks whether user B has permission to execute the procedure, but it does not check whether user B has permission to read the underlying table. Why? Because the procedure and the table have the same owner, SQL Server trusts the chain and skips the intermediate permission check. This is ownership chaining in action, and it's actually very useful. It means you can give users access to a stored procedure without giving them direct access to the underlying tables. The procedure controls exactly what data they can see and how they can interact with it, adding a security layer on top of your raw data. Ownership chaining only works when the ownership chain is unbroken, meaning all objects in the chain must have the same owner. If ownership changes at any point in the chain, SQL Server checks permissions at that point. This is one of the reasons why DBAs often prefer to give users access through stored procedures and views rather than direct table access. And that's your permissions deep dive. To recap, grant gives permissions, revoke removes them, and deny explicitly blocks them, with deny always taking priority over grant. The permission hierarchy flows from server level down through database, schema, and object levels, And managing permissions at the schema level keeps things clean and scalable. And ownership chaining allows users to execute stored procedures and access views without needing direct table permissions, which is a powerful tool for building secure database applications. Permissions are something you'll configure and refine throughout your entire DBA career. The more deliberately you design your permission structure from the start, the easier it is to maintain and audit over time. Subscribe so you don't miss the next video, and I'll see you there.
Generous Academy.